Thank you all for coming. This is actually our 10th Martinis and Lights, so we're very, very excited. Even more exciting is the fact that Peter Ngai, who will be speaking to you tonight, was the speaker at our very first ever Martinis and Lights. 3 years ago, Peter and I spoke to you about the beginnings of OLED lighting and all the potential and how this new light source was going to change how we see lighting and how we can put it into fixtures. And it's so special that now, 3 years later, we have Peter showing us how much that's come to fruition and how much more possibility there still is. I want to tell you a little bit about Peter. Peter is a recognized authority and pioneer in the lighting and technology design. Currently, his work on OLED helped in setting the direction of OLED technology and the establishment of Acuity brand's OLED lighting business. Peter holds over 70 patents on lighting technology design and applications. I'm personally so excited to see him present tonight, so would you all help me in welcoming Peter Ngai.
Good evening. I'm Peter Ngai, and I'm delighted to be here. I think 3 years ago, when I stand in this podium, I said that I talk about OLED, and that was probably more about what OLED could be. And today, what I'd like to come back to you and let you know how much OLED has advanced and what OLED has achieved. And so, and there's tons of information I want to give to you. So without further ado, I will just start my talk. This is a AIA approved a course, and so if you bear with me for an hour, you will be able to receive one unit. And here is probably the yada about about the course description and so on and so forth. Basically, what we want to do here is there's 4 learning objectives here. One is to share with you what is different about OLED versus the rest of all other light sources. The second thing is that we would like to spend a little bit of time on the physics and also the structure of OLED. But the bulk of our focus will be, we would like to share with you the design philosophy for OLED lighting and also the design language that we would use to do OLED lighting design. And finally, and most importantly, what we want to do is to share with you some of the practical implementation of what OLED can do. Okay, and so I would like to begin my talk by asking a question. Last year, towards the end of last year, something very exciting happened to the world of lighting. What do you think that was? Anybody can think about that? Oh, okay. Please. Huh? Absolutely. Yes. Lighting won a Nobel Prize. It was awarded to 3 scientists that invented the blue LED in the middle of 1990s. And that, of course, starts the beginning of what we call the modern lighting. And it propels lighting into the fast lane of high technology. But what I feel, however, is that the more advanced we are into high technology, the closer we are going to bring lighting back to its core purpose, which is what? It's lighting for people. And I believe that lighting, that the modern lighting is the fusion of humanity and technology. And it is with this spirit and this conviction that we begin our talk in OLED lighting. Now, why OLED? What's the difference between OLED light source and all other light source? Well, what I'm going to do is I'm going to show you an OLED light OLED panel, if I can make it stick. And what I'd like you to take a look at is look at the character of this light and figure out what is your gut feeling, your first instinct when you look at this light. What is it, what actually your impression is about this light? This is an OLED light source. Yes, it is. It's 3000K. Yeah. But what about the character of this light? What is your first gut reaction when you see this light source? Uniform. And I feel that it is very calm, very soft, and very comfortable, isn't it? Now, if you think about that, those calm, soft, and comfortable, you don't really use those words to describe a light source, isn't it? Because usually what happens, light sources are meant to be harsh, to be glary, to be uncomfortable. To put that into context, if you look at even a fluorescent light source, a T5XO, for example, it has a brightness of 27,000 candela per meter square. And what about an LED? How bright is an LED light source? It is over 1 million candela per meter square. Some of them to several million candela per meter square. And so that, I think, is the difference. With OLED, the brightness that you just saw is about 3,000 candela per meter square. So what happened to the, what do we do with the rest of the light source? What we do is we will use shades, we will use diffusers, we will use baffles and louvers to keep the light away from us. Isn't that ironical? The first thing we do is to invent a light source, and the second thing we do is to keep it away from us. So, besides that it is more calm and comfortable, what I'd like to do is to show this light source to you again, OLED to you again. Now, what I'd like to do is, if you can actually articulate why you feel the way you felt, and what is the character of this light source. Again, this time, give it a deeper thinking about what this character of the light is. Well, I can tell you how I feel. I feel that the light emanating from this OLED is perfection, is perfect. And there is not a single speck of a blemish that you can find from this light source. And try to find how to describe this perfection. And I can find 3 adjectives for that. And it is pure, it's simple, and it's honest. Pure and simple seems to be very, very straightforward, but honest in the sense that it does not need any ornamentation, anything to make it more beautiful, to make it more perfection. It is perfect just the way it is. You don't need to have anything else to accessorize that. And that's why I call this a very honest light source. And when you see something that is pure and simple and honest, and that is what nobility is all about. And I think OLED is a very noble light source. And that's why we are so excited about this, this light source. Now, what else is interesting about OLED? Well, OLED is very thin. In this case, this is about less than one millimeter in thickness. And of course, thinness is a very important design, a powerful design element. And we will talk about that a little bit later. Another thing about OLED is that there are OLEDs that can be flexible. And I'm going to show you this. This is an OLED. It's very thin. In this case, is probably the thickness of maybe a couple of paper. That's all it is. And it is flexible. So again, think about flexibility and what we can do in terms of lighting design. And what else? There are many different form factors. You can have something as small as a 2" by 2" all the way to about 12" by 12". And you have, and also many shapes in between as well. For example, here is one that is that's larger, and I'm going to show that to you. In this case, it is a 4" by 12". So there's a lot of things that we can do with this kind of sizes, this kind of size. Now, okay. What else is very special about OLED? OLED is cool to touch. You know, unlike LED, where all the heat has to be dissipated from a very small point source, OLED is an area source, so that there is plenty of space for the light, for the heat to dissipate. You can touch the OLED all day long, and you will not feel any temperature difference. And so, with that in mind, that with OLED you don't need to have any kind of heat management. You don't need to have a heat sink or any kind of active or passive heat transfer means to take care of the heat. And of course, OLED is sustainable. In terms of sustainability, just think about the form factor. It's thin and it is light. It reduces the amount of luminaire housing material. As a matter of fact, we will also go into that a little bit more detail later on. And of course, it reduces the footprint of the packaging and the shipping. And it has no mercury in its composition. So again, it's very sustainable. Now, what we'd like to do is just to go into the technology of making OLED lighting, why make OLED lighting so unique. Well, LED was invented in 1962, and OLED was invented about a quarter of a century later in 1987 by the two gentlemen here, Chin Tang and Steve Van Slyke, yeah. And it's kind of interesting, most of the inventors, whether it's Marconi or Bell or Edison, they're all dead. But these two guys, they are alive. And I talked to them. So, well, anyway, I just think that it's kind of funny. Okay, now, LED is based on the inorganic semiconductors, right? OLED is actually pretty much the same, but instead of inorganic semiconductor, we actually use organic semiconductors. By organic, we mean that it consists, the electroluminescent material consists of carbon compound. And the idea here is basically just the same as LED. You have a N-doped material, and you put it next to the P-doped material, and you pass electricity through it, you will emit light. In terms of structure of the OLED, it started with substrate. A substrate, you can be a piece of very thin glass or plastic. And on top of the substrate, what we do is we deposit a very thin film of ITO, Indium tin oxide. Indium tin oxide is a conductor. It's like a copper, except that it is so thin that it is transparent. And on top of that, the indium tin oxide, we put layers and layers of electroluminescent material. And on top, we put a cathode, which in form of a most likely an aluminum sheet. And then we encapsulate this device to protect it from moisture and oxygen. And if you pass electricity through it, then you will have light. Now, all these layers and layers, the modern OLED layers, you can go all the way up to about 15 different layers. But the entire thickness is much thinner than a piece of human hair. And most of the high technologies are in two areas. One is in the material, and one is in the manufacturing technology to be able to have consistency of each layer. And all that has to be done within in the dimension of microns. And that is basically the architecture of OLED. Now let's go into the performance of OLED. 3 years ago, when I stand here, I told you about the performance of OLED. And now 3 years later, the advancement of that OLED performance is really astounding. I remember 3 years ago when I talked about the efficiency, it was very, very low. It's something like a 20 lumens per watt. Now 3 years later, it's 80 and 100 lumens per watt. In terms of color temperature, we have three different color temperatures: 3000 K, 3500 K, and 4000 K, of course. And in terms of the color consistency, it is now plus or minus 2 macadam ellipse. That is very, very, very good. If you think about in terms of LEDs, most of the LED specification in terms of color consistency is roughly about 3 to 4 macadam ellipse. And the best LED is about 2 macadam ellipse. So the OLED color consistency can rival the best of the LEDs. In terms of the luminance, it is about 3,000 candela per meter square. It is not that OLED can only go up to 3,000 candela per meter square, but we purposely make the rate lumen to be that luminance to be that number, because we feel that anything more than 3,000 candela per meter square will actually create, and so we want to avoid that. But if there is an application that requires higher luminance, we can always drive the OLED higher. In terms of lifetime, I remember that I was telling our audience that the lifetime at that time was roughly about 10,000 hours. And now, if you drive it at the rated brightness, it is 50,000 hours. And in a lot of the applications, you really do not need 3,000 candela per meter square. If you drive it down to 2,000 candela per meter square, you actually can get 100,000 hours. And for applications like decorative lighting and sconces and so on, you can drive this OLED to about 1,500 candela per meter square. And at that time, the lifetime is over 150,000 hours. And that is the kind of advancement within this very short 3 years. Efficacy, I already told you, 3 years ago, it was about 20 lumens per watt, and now it's about 80 to 100 lumens per watt. In terms of reliability, now we are about 1 in 1,000. That means to say we do not expect any a failure rate of more than 1 in 1,000 at this time. And the industry, the OLED industry, is driving towards 1 in 10,000. And their eventual final goal is to be 1 in 100,000. So that's where we are. I want to talk about the color quality of OLED. But it's kind of interesting. Just last week, IES came out with the TM30, right? And that is a new method of evaluating light source color rendition. Remember, this is a TM, that's a technical memorandum. It is not a IES standard. And so it depends on how the rest of the industry support this new IES method. But I think it is that I must share with you, what this new TM is when we talk about the color quality of OLED. In the conventional color rendition index, we have one single index, which is the RA, right? So when you have an RA of 85, for example, that is very good color rendition index. But in the new system, we have actually two different metrics. One is the RF. RF is the index of fidelity, and it is actually very similar to that of the old CRI, but instead of 8 color samples that we take into account, this time we take 99 samples. So it has a much broader range of specimens to come up with this number. If you have a RF of 100, that means to say you got perfect fidelity, and if it's less than that, then you have less fidelity. And another metric that is introduced is called the RG. RG is the consideration of the color gamut. That is to say, the ability of the light source to increase or to reduce the chroma. That is to say that the color, when you have a high RG, it can be over 100. You have an RG of over 100, that means to say this light source is going to make the sample more vivid, that's more saturated. And if you have a RG of less than 100, then the color is more muted. And so you use these two numbers to identify, the quality of the color. So anyway, I must do that. So with the 35, like the 3000K OLED, in our conventional way, you can see that it has a CRI of 89. Of course, it's very high. But in our new metrics, the RF is equal to 86, and the RG is equal to 98. One other thing about the new method is that we actually have what we call the color distortion graphics. It actually tells you how the color is distorted. For example, in this case, we can see that there is a little bit mute desaturation of the color near the pink and the red area, and a little bit exaggerated in the blue area. It tells you precisely what's happening. And this vector graphic not only tells you that, but it also tells you the direction that is changing. You can see those arrows coming from the black circle, which is the standard, to the test sample, which is now how this is diluted and towards what direction. And you can see with the 35, the same thing. You have a CRI of 86, and you have a RF of 82, and also the RG of 95. The other thing that is kind of interesting, of course, is the DUV. It has a minus 0.0013. That means to say that light source is very close to the Planckian curve. And 0.0013 is a very, very good number. And same thing for the 4000, 0.004. Now, how does that compare with the LED? I pick a good CRI LED, which in this case is what? Is 88, and with a 3000K OLED at 89. And you can see that the RF and RG is exactly the same. And again, if you look at the graphic distortion, is also exactly the same. What is said is that the color quality of OLED can now match the best color quality of the that LED can offer. Now, what about the efficacy of an OLED versus that of an LED? You see that for the with with OLED, as I told you, with a high CRI OLED, the efficacy is 80. But with the same kind of CRI with LED, it's about 120. And you say, gosh, there is a tremendous difference between these two. But we have to understand that with LED, it is the chip efficiency. That's to say, when the LED is driven at 25 degree junction temperature, and no LED is driven at that temperature in any practical application. When you put it into a luminaire, the temperature will be higher. And also there is an optical loss. I call this a conventional luminaire. That is to say that it's like an LED, you have some kind of a diffuser underneath. And DOE estimate that the loss is about 13% for thermal loss, and about 13% for the optical loss. And so the actual net efficiency is about 90. And for OLED, as we said before, OLED, there's no thermal loss, nor there's any optical loss, because the amount of light that's giving out from an OLED panel is exactly the same kind of light that you are going to receive from the luminaire. So in this case, you see the final difference is basically about 11%. And I don't believe 11% is the hindrance when you want to design your lighting system with OLED, because there are many other virtues of OLED that compel you to use OLED instead of LED. Another type of luminaire is what we call the low-profile type of luminaire, the edge-lit type of with edge-lit LED. In this case, everything is actually pretty much the same, except that the optical loss in this case are higher. And if you look at the luminaire efficiency eventually coming out from the luminaire, it's basically the same. So again, within these 3 years, OLED came a long way in terms of increasing its luminous efficiency. And in terms of lifetime, we already talked about the 100,000 hours and 150,000 hours and 50,000 hours. This number, tell the story, by itself. I don't even want to go into detail of that, and you can see those numbers. And another aspect of OLED is that it is very expensive. 3 years ago, we actually bring out some of the numbers of a luminaire is in the neighborhood of $20,000. But I can tell you today, this situation changed tremendously. In the 4 years, from 2011 to 2015, if you have a relative cost of OLED at that time is 100, at this time is 4. There's a 25-fold decrease in terms of the cost of OLED. And you already have may know that there are some OLED luminaires that is at a very reasonable price. So again, the myth that OLED is very expensive is now gradually, we hope that it will be dispelled. Now let's, after we finish all those preparatory kind of subjects, let's go into the OLED lighting, the philosophy and the language. Well, I think when we consider the role of lighting in the play in the architecture, once we move beyond safety and the ability to see, then the purpose of lighting is what? Is to complement and bring the architecture to life, and with or without the presence of the luminaire. But with OLED, however, OLED is much more focused to our consciousness. As we say, the character of the light demands that we want, demands it to be seen. So when we design OLED lighting, the luminaire or the light itself are the subject, are subject that need to be appreciated and to be noticed. So in this case, what we want to do is to create luminaires that is compelling. If we when we design OLED, we just cannot simply design something that is adequate. We want it to be extraordinary, to be distinguished, because we want to celebrate the light source and also which demand it to be noticed. Now, this is the first philosophy of OLED lighting. The second philosophy is very interesting. I think I showed this 3 years ago, and it's so powerful that I want to show this again. This is supposed to be a picture showing the cutting edge technology of OLED, that is very thin, that it is bendable. But what I see is something totally different. What I see is a pair of human hands actually touching a light source. When is the last time you touch a 400-watt metal halide? You just don't do that, right? But all the previous paradigm about light source, that it is harsh, that it is distance, that we want to keep it away from us. But with OLED, what we want to do is we actually want to get close to it. We want to touch it. We want to befriend it. And that is the very special and precious character of OLED. And so what we say in terms of is the design philosophy is that OLED actually moves beyond just simply function. It is about emotion. And it is the emotional part that when we design the OLED lighting that we always want to remember. Well, and, oh, okay. I forgot I have this, I have this slide. And so when we design our OLED lighting or OLED luminaire, the OLED actually express the emotion, whether it is for a sense of companionship or privacy or playfulness, whatever the emotion, we want that OLED to be able to express, not just simply a beautiful object. What are the vocabularies that we use when we design OLED? Thinness is come to the mind, of course. And as a matter of fact, if you look at this design, this luminaire is actually very thin, so thin that it has a form, but actually without volume. In this case, we are actually celebrating the form, celebrating what is not there. Now, and this one, again, bring out another aspect, another vocabulary, which is simplicity. In this case, the light is the star. I mean, everything else is receded to the background. The simplicity is that we are actually celebrating the light as it is. We don't need any ornamentation to make it look beautiful. It is just perfect the way it is. Well, if we say that the last example, that the light is the star, in this case, the light is the luminaire. There's absolutely nothing else. There's nothing else to it. And the light actually become a material. It is like bricks to a bridge, or fabric to a garment. It is the material that actually form the construction of the luminaire. And how simple can you get? Another aspect of OLED, as we said before, is because it's emotional. We want to get close to it. There is a human connection with this. In this case, in these two examples, you can see that the OLED actually forms a very soft volume of light that can actually embrace the occupant. and it actually have a sense of, promote a sense of companionship as well as the collaboration. In fact, I always say that there's no way that you can fire anybody under this lighting system. In fact, if you bring somebody in and trying to fire that person, you might end up giving that person a raise. Yeah. And so in order to do that, we need to have luminaires that actually connect with us. Through its design, through the brightness, through its form, through its gesture, it has to be sympathetic to our emotion. And of course, with OLED, you are free to be creative. There's no regimen. There's no 8x10 layout or 8x8 layout that you have to conform. In a way, regimen is a thing of the past. Closeness. Closeness, of course, is what OLED can do. OLED encourage us to bring the light source towards us. And for example, in this case, you can create a personal domain and enveloped by a very soft volume of light. It encourages individual focus. What else we can talk about OLED? OLED is made out of tiles. The tiles made out of light. And with tiles, you can create modules. And of course, tile has been used since the Greek era and the Roman time. We use tile to do mosaics and create decoration and as well as functionality. And at this time, we are doing the same thing. We are using OLED to create pattern, OLED light. We use light to create patterns. And as a matter of fact, we can create patterns with something that's very, very simple. In this case, perhaps a tri-module and a straight module. You can create infinite number of patterns. And whatever patterns that you created, it is beautiful. It's impossible for you to create an ugly pattern with light. And of course, we can now also, with OLED, to create a drape of light. And whether it is use the drape of light, it can be functional to light up a space or as a decorative element. It can be a sense of place or a gentle transition, from one space to another. These are all the design philosophy and the vocabularies that we use to do OLED. Now, how do we implement that? Those design philosophies and those languages? Well, first thing, we all very obvious. Sconces, markers, and decorative lighting is a very prime candidates. You create rhythms, define the pathways through repeating luminance elements. Or we can actually simply free form. They are just as beautiful. Or we can create elegant accent on the wall, and you can also serve a purpose. One aspect of OLED is that it is diffuse. It is diffuse lighting, and with diffuse lighting, we know that from our prior experience that unlike the focus light, where you will put almost like a sheet of illumination on your working plane. Diffuse lighting will put some light on your working plane, and then the rest on the wall, and then you can be reflected on the ceiling. What it does is that it creates a volumetric brightness. You make the entire space looks bright, and you satisfy our psychological appetite to brightness. And so this is of course the most important aspect when we in seeing make the space looks cheerful and also more definable. Now, I'm sorry. So, and as you can see that there are many implementations using OLED, as general illumination. But this diffuse light, where you create a sense of, a sense of brightness, can bring it all the way down to the personal level. And in fact, the OLED actually help us to introduce another way of lighting our personal space. Of course, we know about ambient lighting, right? And what does the ambient lighting will do? You will actually blanket the entire space with a certain amount of illumination. For example, in this case, it's 40-foot candles. What is the character of those lights? It's glare-free, it's uniformly illuminated, a higher energy cost, and has a subdued visual interest and minimal personalization. And of course, what do? Well, we want to save energy, right? For the last few years, all we heard about is energy savings. It seems to me that energy savings means everything, but it is not. But anyway, what do we go? We go to task ambient. With task ambient, what happened is that we use a minimal amount of ambient light. In this case, example is about 10-foot candles. The rest of the 30-foot candles is actually created by a task light, which focus on the task area. But what happened to the people, to the objects within this immediate surround is actually in darkness. It gives you lower visibility, and it actually reduce the interaction, actually impede the interaction between the occupants, and it does not make create any clarity of objects that's within this personal space. So, what can OLED do? Well, this is actually a comparison between ambient lighting and task ambient lighting. And what OLED can do is actually introduce another philosophy when we want to light a personal space. It introduces a separate layer of light, which I call surround. And so it is what we call the task, surround, and ambient lighting. In this case, the task illumination is contributed by ambient light, by surround light, and also task lighting contribution. The reason to have the surround light is basically the same thing. We want to create a certain volume of light within that immediate area surrounding us. And so that there are more clarity, it allows people to be able to see each other, and it makes the entire space more acceptable and more cheerful, and as a matter of fact, more functional. And you can see, the three different type of lighting system. The task, surround, ambient, they both save energy as well as give you more clarity and promote the interaction between the occupants. As a matter of fact, I did a whole research in this area, and if you really want to know, I can send this to you, and you will be a very good medicine for sleeplessness. Another practical implementation of OLED lighting is actually we bring LED into the lighting system, because if we can bring LED and OLED together in a holistic way, and take the strength of OLED and the strength of LED together, we can actually create something that is very synergic. How do you say that? Synergical? Synergistic. I'm sorry. So, of course, we know what OLED can do. We already talked about that. But LED is a very strong source. It packs a lot of power, and it is also very easily controlled optically. And so, for example, in spaces where you want to have enough illumination, you may be able to create indirect component of the light using LED, and the downlight with OLED. As a matter of fact, in this case, we also have two focusing LED downlight to highlight the objects below. Or in this case, we can actually create luminaires with the top piece going as indirect and the downward facing piece using OLED. And it can be used in many, many different applications. Or in this case, we can create luminaires that is very conventional, but yet it is very refined. It is very functional, and you use the best of both worlds. And you can even turn it sideways. There's many things you can do, and we can be a little bit more want to feature this and to be more special. We can create luminaires like this, and using OLED and LED. And for example, these are some of the examples. Now, in the past 3 years, there's many different many installations that has been that try to use the goodness of OLED to create their space. And what I'd like to do is to share with you 2 case studies, and I select them with with great deliberation. The first one is an office 16500 in Emeryville, California. The office has a stunning view. I mean, it is looking into the San Francisco Bay Area. The room is beautifully located, and the challenge for any designer is that it has to compete with the best of what Mother Nature can offer. In this case, there is no upside to it. If you do not do a good job, you can only go down. And so the purpose of the design is less about enhancing the space, but actually not to mess it up. And I think that is the challenge. And because of that, the designer, Aisha Atari, tried to use OLED to solve this problem. As a matter of fact, what she did is she had tried to use various different layouts, in this case with the luminaires on the ceiling. And then she also tried to use pendant-mounted OLED luminaires and a combination of ceiling-mounted and pendant-mounted luminaires. And finally, she decided on this, which is that it is pendant-mounted at a random distance, and you can between 12 inches and 24 inches away from the ceiling. And basically, it's a 12 foot by 16 foot by 9 foot space. The maintained illumination is around 30 plus foot candles, and the power density is 0.41 watt per square foot. And so this is what the final installation looks like, and this is what it looks like during the nighttime, or quite close to nighttime, and it's a beautiful space. And with the OLED, it did not diminish its beauty. And after it is done, and you can read Aisha's comment. Indeed, this time when people say "wow," they not only because of the scenery, but also because of the light, and that is a successful installation. And now I want to share with you another space. This is a very underprivileged space to me. It is a basement and turned into a home office. And the goal of the lighting is actually trying to take the space out of its misery and turn it into a productive and cheerful space. But what are you going to do with this space? It is a very low ceiling. The ceiling height is 7 foot 5 inches. What are you going to do with a space like that? You use pendant mounted light? No, you cannot. Do you want to use a direct cans or 2x4s? You can't, because the ceiling is so low. You're going to burn a hole in your desktop. And so what happened is that Leslie North came to us, and she said that she wanted to try to use OLED. And the idea that she has is to create a very use OLED to create a special configuration that actually looks very nice on the ceiling, and yet it is very close to the ceiling. In this case, the OLED is actually about 3 inches away from the ceiling plane, and is actually floating just right below that. And again, she used various design, and finally she selected the one on the lower right-hand side. And the size of the room is 14 by 20 by 7 foot 5 inches. She was able to accomplish that with 30-foot candles, and the power density is about 0.63. And after she finished, this is what the space looks like. Very, very bright and cheerful, especially when you have a very low ceiling. It's very oppressive. And what you want to do is to expand that, to make it looks filled with light. And you will see that this is her comment, and that it is very inspiring. It makes the space look a lot better. And when people walk in, just like what would be expected, people look at that OLED and they want to touch it. Now, we have talked a lot about what the OLED can do. And I think in conclusion, you can see that OLED can be very functional, and it can be aesthetically pleasing, and it can be emotional. And I think we can design our space to be glorious and gorgeous. Isn't it? Thank you very much.
Thank you, Peter. Does anyone have any questions? No questions?
Well, I think, Peter, you should tell us about the fixtures hanging here.
It's the AIA.
That's okay, we're done.
It's over.
Oh, okay. Yeah, this is a concept fixture that we actually shown at the at Light Fair, this past Light Fair in May, and it is the hybrid. We call this the Duet SSL. We have LED uplight and OLED downlight. And what we were able to accomplish is something that is a luminaire that's very, very thin. As a matter of fact, it is only about 5/16 of inch in thickness. It's like for the curved one, it's almost like a ribbon of light. And for the straight one, it is more conventional, but it is very refined. And I think that is where we can capture the preciousness of OLED. It is something that no other light source can do. It gives you the sensation of brightness. It satisfies your psychological appetite to brightness, and yet it is very welcoming and it's very pleasing, and it connects with us. I think that's all I can say. And
So Peter, the top is LED uplight?
yes,
And then,
the bottom is OLED. Yeah. Mm-hmm.
Beautiful. I think we had a question here.
Yes, sir.
I know that a lot of the problems with LEDs and OLEDs is that the directionality is very forward or perpendicular to the light source. Have there been attempts to make spherical OLEDs?
Spherical
or curved? It seemed like the composition of it was made so that it was only a flat light source.
Yes, it's flat, And when you say curve, you can only do one dimension. And the technology has not get to the point that you can say create a hemisphere. At this time, we cannot do that. Yeah,
Okay.
we are asking our technology partner to try to see if it's possible. It is, the problem there is in the precision of the layers of those electroluminescent materials. You are talking about a few microns thick, and they have enough trouble just deposit in a flat surface. Have it curved, especially in two-dimensional and three-dimensional curve, they cannot do it. Not at this time. I hope they can.
Any other questions?
So we're the equivalent of the driver. I just see the two wires. It's coming down, what, at 12 volts?
No, the voltage, it depends on how you wire that. For an OLED, an individual piece of OLED will have a forward voltage of roughly between 6 volt to 9 volts. Yeah, and so it depends on how you do that. We can bring down 40 volts.
So the driver part of it would be equivalent to the other LEDs?
Yes, you
with
can.
With the dimming and...
Yes, it is exactly the same. Mm-hmm.
Thank you.
Sure.
Anyone else? No? Yes? No. Well, thank you so much, Peter. Everybody, let's hear it for Peter one more time.
Thank you.
So Peter will be sticking around and mingling outside if you guys have any other questions for him or want to grab his ear. I know he thanks you all for coming. We did offer AA credits for this presentation. The certificates are sitting right on the counter right outside this room. So, and if you can't find them, just let me know. Thank you guys all so much for coming.